All right, the topic is diffraction. So let's write it down. Diffraction. So this is the effect of waves seeming to, if you want, bend around corners. So we'll draw a picture to represent what we mean. And okay, so let's say that these are incident waves. Okay, on a say this is water. Okay, and these are two barriers. All right, blocking this water from getting into the rest of the tank. Okay, so let's just label that as water. Now, what we'll see, we put this in a wave tank, is you are going to get, on the other side of this, waves coming out that are curved, okay? So this will almost act like a point source of interference, okay? So you get this kind of an effect going on. Oops, that's these. Okay, so the waves are sort of spreading out in all directions. The source. So there's no real, like, if you want, shadow where one would be able to hide from the wave. So if we were to have a boat, and we were to put a boat in here, it's not a good way to draw a boat. Put a boat in here, all right? Even though that boat is away from the opening to this channel, if you want, okay, the waves can still get in here. Now, the power of the waves is going to be less than the incident waves over here, right? Because the energy transferred in is only the energy that actually like fits in here. What happens to the energy of the waves that strike the concrete barriers? What do you think will happen to that? Yeah, they'll reflect, right? They might even put some of their energy, if this is like a big breakwater of some sort, they might even put some of their energy into like rocking this thing or moving this thing. But if these are rock solid, right, you're going to just get reflection there. So the actual like amplitude of the waves passing through here would be lower than the waves over on this side of the breakwater or barrier. And but that being said, you would still be able to have waves here. You're not going to have like a just like a beam of waves traveling this way and over here there's no waves. Okay. Now the question is, why does this happen? So back in the 1600s, a Dutch scientist named Huygens, that's a Y and a G, Huygens, explained the waves in this way, or diffraction in this way. He said every point on a wavefront acts as a source of new waves. So another way to think about this is he said, imagine that a plane wave, I'm going to draw a few plane waves here. Okay, so these are waves in a line. I don't really like where that is. Okay. Every point along this, oops, every point along this wavefront, oh dear, oh my goodness gracious, we're good, we're good. Don't panic everyone, we're fine. Acts as if there's an infinite number, right, of waves, and therefore any point along here can act as a source of new waves. So he said to almost think of a wavefront as just an infinite amount of little wavelets, side by side little curved wavelets, just waiting for their partners to get blocked off so that they can continue as a source of new waves. So every point on a surface acts as a point source of new waves. Okay, so you get this kind of like propagating effect. So we call these things wavelets. So if something like this, if you think about it in that mentality, right, as it comes to a large barrier, and we look and see, and we have all of these little wavelets coming to the corner, okay, and we see what happens here. Well, these ones, right, bounce on each other, but this one on the corner, right, now has the opportunity to act as that new source of waves. So we get this like curving pattern as we go around the corner, because this little corner right here acts as a source. So let's look at that even more like in depth. So let's imagine that your substance that the wave is traveling in is kind of like this. Like it's like a whole bunch of particles, right? And these particles are interacting with each other. And this is kind of like sort of a view of the way that matter is set up, right? It's got particles inside it, and those particles are somehow attached to one another. So the way that helps me to imagine why Huygens' idea is true is, let's imagine that these guys are all attached together by a network of springs, okay? And every one of these is attached to its nearby partner by springy springs. Okay, so you have this big like network. And in air or something like that, this would be in 3D, but in water, the surface of water anyway, it's sort of 2D, right? So if we were to oscillate everything here by giving it one big, forward push, that would enter a traveling wave in here, right? We would compress and then expand, and we would get this wave propagating through here, right? So now let's say that we have a wall here, right? Blocking it. Well, this is still connected to one that's in here, right? We have these ones over here. Sort of drew that in the wrong place, but I hope you get the picture. So in comes this wave energy, right, as one big sort of wash of energy, and it gets to this point, right? Here's the wave front. Well, energy is blocked from passing into here, right? Because there's a barrier. But it's not blocked from here, so it continues into this one. So what it'll do is it'll oscillate this particle. Well, this particle is connected to this guy, and that's to that guy, and that's to that guy, and to this guy, and so on, okay, by these springs. So if I start to shake this one, well, that's going to shake this one, right? If we imagine that they're all actually attached, okay? That's going to shake that one up this way, and this one down this way, and this one down this way, and you're going to get this propagation of waves in this sort of circular pattern from the opening. Does that make sense to you?